Welcome everyone to this really short talk about the upcoming version of SysML that is called SysML version 2. And the focus of today will be really a short view about what might be the possible technical depths when deciding for the migration towards this new version of the language. So the agenda of this talk is a brief introduction about model-based system engineering and SysML in general, then some selected highlights about the new upcoming version, and then a discussion about general migration problems and also specific problems related to SysML. And then we will conclude with some discussion. Yeah, if you have not enough time to follow the presentation, so the spoiler is that SysML version 2 includes a number of interesting features that for sure will make the interest for adoption high. But on the same, let's say at the same level of importance, it has to be understood that we are talking about a radically different language with respect to the existing ones. So indeed, we can talk about properly new language that is called SysML version 2. And naturally, depending on the kind of use that you make of SysML inside your company, you might go towards different degrees of technical depth. So I think most of you know about the problem of the growing software ubiquity. So what typically happens is that the amount of software that is adopted in products is increasing, and even in those products that software was not part at all of the product. And typically what happens is that software breaks the boundaries that typically were created by, for example, separate mechanical parts of a vehicle, for example. So today, for example, you have to be worried that your system manages in a separate ways the braking system and the entertainment system of your car, for example. Added to this, there is an ever-increasing pressure for shorter lead times. And this, again, is something that is related to software itself, because since it is known that the software that is not updated at least every 6 months is considered dead. So this means that a lot of products are subject to pressures for new updates or new refinements of what is available. And this makes, in turn, to grow the pressure towards delivering as soon as possible, and also to have a higher degree of confidence that what is delivered is of a good quality. And this also moves the focus on reuse of a lot of components, for example, or parts of the system, simply because it is much faster to reuse what is already developed and tested than developing each time from scratch. So model-based system engineering has been around for a long while, and the main view of this kind of software engineering approach is that you develop the system starting from higher abstraction levels. And here, for higher abstraction levels, we mean levels that are not, for example, implementation code or in general, just development documents. And this because, of course, since the complexity grows, just looking at the code becomes untractable. So, for example, the shorter lead time is very difficult, if not impossible, to achieve. Just looking at the code and not having this higher level of abstraction documentation. That might be models or other kinds of architectural representations, specifications, and so on. So SysML was introduced indeed for this reason as a general purpose language for system modeling. And it originally was born as a language extension, a profile of UML. And if you might think why, of course, one straightforward reason is that if you develop SysML as a profile of UML, then any editor of UML will be able also to open a SysML model. And this is something that is extremely practical. But in the long run, it also posed a lot of limitations to what SysML could do. And so if you see a current version of SysML, what you have is a representation of the system into blocks. So what you see is called technically a block definition diagram. And then inside the diagram, you have several components that are interconnected. I selected this example on purpose because, as you might see in this diagram, there are no apparent software parts. So what we are talking about is a water distiller, a water heater, and a radiator. Then maybe in the water heater, there will be some piece of software inside. But as it is shown right now, this is a simple system representation with no further references to software, for example. So if we take the definition that has been given for the standard specification of SysML, it is said that it supports the specification, analysis, design, and verification and validation of complex systems that might include hardware, software, information, processes, personnel, and facilities. So basically, it's a language to really represent any aspect of the system. And another important aspect of this language is that it really pushes toward an onion skin system specification. That means that you basically have a recursive structure to define arbitrary levels of detail of the system. And if we go back to the previous diagram, what we might notice is that, for example, the radiator component on the left will be maybe left as it is, while, for example, the water heater will have on its own another block definition diagram in which it is possible to specify what are the inner components of this water heater, and for example, specify that there are some sensors, for example, for checking the temperature of the water. There might be a controller that is developed as a software piece that decides when to heat the water and when not, and so forth. So why we are going towards SysML version 2? If we want to summarize it in 4 main points, we can say that it is because of a formal foundation, new meta model, text annotation, and so first of all, formal foundation. If someone for all of you that had experiences, for example, with the UML, that is a general purpose language, one of the most relevant issues is that if you want to have a layer of semantic checks, for example, on top of what you specify with UML, you need to do those checks by hand. So you need to introduce, for example, OCL constraints to check that what is represented in the model is correct. What is introduced in SysML instead is what is called a kernel modeling language called KernML that is derived from formal logic, and this allows to have embedded semantics validation checks. So, for example, as we will see later in an example, it is possible to have a validation check that when you specify a flow, the units that are assigned to the ports are compatible. So you cannot connect, for example, a kilogram port to a meter port. So the types that are involved in the connections between the ports have to be compatible. This second point is a new meta model, and here it comes really the fact that this version 2 is a completely different language with respect to the previous versions. So the language is derived from the object management group standard for meta modeling that is called MOF. And I mean, this is a technical aspect, but the fundamental thing is that basically uses the same instrument that is used to define UML. And but the language is defined in a complete separate way. And this releases SysML from the constraints that were embedded in UML, and on the fact that a lot of tool providers implemented SysML as a profile of UML. So for example, in UML, when you have a type declaration and then you have instances of this type, then all the instances must implement the class declaration in the same way. While, for example, in SysML, it is possible to instantiate types with specific values. So values that are properly defined only for a specific instance of a class. And then there are other very interesting features. So, for example, the language embeds the declaration of feature diagrams and variants. That is something that is extremely relevant, especially for systems that use, for example, product lines in the development. Another very relevant news about this new version is that the default notation for the language is text. And this might seem contradictory, because when someone talks about modeling languages, our head or our ideas go directly to think about diagrams. But instead, the choice has been to use a textual notation as a base, and this allows to derive then a multitude of alternative notations based on the source model that is defined as text. So, for example, right now, you can define your SysML model as a Jupyter notebook, and then starting from there, you can export your model in Tom Sawyer tool and get the diagrammatic visualization of what you defined textually. And this, if you think it practically, it's convenient, because with text you can skip, for example, the graphical rendering of your models, or where the different components that you defined in the model are placed in the diagram, and so forth. And the least but not last point is standard APIs. And this is really thought to enhance the opportunities for tool chaining. So what it has been defined is a platform independent service and operation definition for basically interacting with the SysML models. So it is possible to have this layer for which it is possible both to have read operations about the model. So, for example, to query a model to extract a specific component or the properties of this component, but also to perform operations. For example, if you are coming from another tool and you want to propagate the changes from these other tools back to your SysML model. So if you are curious about how the SysML version 2 model looks like right now, it is like this. And again, as you can see, it looks more like code, but indeed it's a text-based model. And here, I mean, I don't want to go into many details. What I wanted to stress is that, as you may notice, in the import, we are getting in some units of measures and also functions about the scalars. And then when we, for example, declare a new block that in SysML version 2 is called part def, in this case, we define a vehicle. And then for this vehicle, we create a constraint that needs to be true for any instantiation of this part. And here, what you may also notice is that the attributes of this block that are the engine and the transmission have a mass, and the mass is typed as mass value. And here it comes back what I was saying before, that you will not be able here, for example, to define a length measure for these properties. As soon as you do like that, then you will get an error because the types are not compatible. And this is done due to the formal definition on which the language is based. Now I have 9 minutes, so it's okay. I will shortly talk about the migration problem. So at this point, you have a very short introduction about the new version, and you might think, okay, it could be good to migrate towards version 2, but what will happen to the models that have been already developed? And in theory, all the models that have been defined with the previous versions of SysML will become invalid. And this is because, as we have seen, for example, we are talking two complete different languages. In one part, we have block diagrams. In another part, we have part definitions, and so forth. Anyway, as it happens typically in this case, is the object management group that is indeed behind the standardization process is planning for guidelines and support for the transition. Anyway, what typically happens with this kind of language evolutions is that in general, you might face three kinds of changes in the language. One kind of changes that are technically called non-breaking, but you might think as a kind of changes that do not affect the current models. And this might due because, for example, it is elements that are only part of the new version of the language. So as we were talking, for example, SysML version 2 will have support for variants. And since the previous version didn't have this support, so you will have no problems with these new elements. Then there will be another category of changes that are resolvable changes. And here for resolvable, I mean that you might have also some automation mechanism behind the scenes that creates this translation. And in this case, we are talking about elements that have a precise corresponding element in the old version. So as I was saying before, a block in the previous version of SysML will become a part def in the new version of SysML. So you can create some script, for example, that goes through the language. All the model instance and migrates all the blocks into corresponding part definitions. Then there are the third categories that are so-called unresolvable changes. And here, again, it means that the human intervention is unavoidable because there cannot be made a decision in an automated way. And for example, here I took a case that is for ports. So in the upcoming version of SysML, ports are not part of a block anymore, but instead what will happen is that a block or a part def will expose interfaces that have to conform to port definitions. So in some sense, port definitions or ports become something that is that are independent of blocks. Now we come to the technical depth, and here, as I was saying, in the short term, most probably you will be able to open old models even with the editors for SysML version 2, but of course you will not be able to profit of the newer features of the language. And yeah, well, one important thing to notice here is that the most probably the standard will be released by the end of this year, so by the end of 2021. What is instead more important to reason about is in the long term. So in the long term, what will happen is that depending on what you use about SysML, so which concepts, which diagrams you use about SysML, and also how you use SysML. So do you use for documentation inside your company? Do you use SysML as a document that then is used for official reasons, for example? Do you use SysML to generate code? Then depending on these kind of uses, you might have more or less wide and deep impacts about your models. So for example, you might think that if your product will go on for 20 years and you just released your product with the documentation that includes the current version of SysML, in 5 years your documentation will be obsolete because most probably there will be less and less tools that will read older versions of SysML. And as last slide, a little of the advertisement. So due to this interesting problem, Antonio Martini and myself, we are going to propose a project inside the Software Center initiative. So by the end of the spring or the beginning of summer. And indeed, what we are interested to understand is what is the typical use that is done of the current version of SysML, and then have a kind of understanding about what might be the plans to prepare for the migration. If someone is interested to the specification, there exists a GitHub with this link that I put here at the bottom. And there you can find both the current releases that are available both as an Eclipse plugin and as a Jupyter Notebook. And also you can find the printed documentation. So, for example, PDF files with the kind of user guides about what is in the standard.